Welcome to Marathi AML channel. Today we are going to see the second part of classification chapter. In today's lecture we are going to see a precision recall. I have already explained you what is a precision recall in depth in last lecture, but we will again see uh, with the example what is precision and recall, and then after that we will see the trade-off between the precision and recall. Then we will see the precision recall curve, and at the end we will see the ROC curve. Now let me explain you once again what is precision and what is recall. So precision is nothing but the how many values, okay, how many values are correctly predicted from the given prediction, from the given positive prediction. Now when I say given positive prediction means what? Now if you look at this confusion matrix, you can see this column, these are the positive prediction, these are the positive prediction, but out of this positive prediction we know that my model only predicts three value correctly. Okay, so my model says these four values are number 5, but from which actual how many numbers are 5? Only three numbers are 5. So this is called as a precision. So out of four positive prediction, only actual three values are positive. So this is called as a precision. Now if you look at this precision, you can see the formula is become, let me write down the formula, which is very straightforward, and it is become one, um, just a minute, give me 1 minute. Yeah, yeah. So if you see, look at the formula become fp, sorry, tp, that is the actual positive, upon tp plus fp. So this is my positive prediction. From this total positive prediction, what is the actual value my model got predicted? This much value my model get predicted. So this is called as a precision. Exactly opposite, so the important factor which needs to be focused is a fp. Now let's look at the second, that is recall. Now what is a recall? Recall is nothing but the from my total actual prediction, okay, from my total actual prediction, how many values are how many values are actual positive, it is called as a positive, which is called as a recall. So if you look at this, so the formula wise my recall become, these are my actual positive. From this actual positive, how many values are get predicted, that is called as a recall. So these are actual positive, right? That is 5 plus, so tp plus fn is my actual positive, from which these many values only get predicted, that is 3. So out of 5, only 3 values get predicted in the in this recall. Okay, so this is called as a recall term. I hope you understand what is a precision and what is recall. Now if you want to calculate the precision recall, then you can use the scikit-learn matrix. Okay, so how you can use, you just use the sklearn. Let me um, let's go to the notebook. If you can see, there is a package available called as a precision score and recall score. You can import from the sklearn and just pass the two things. One is the these are the my actual class, and these are my predicted class. So from where you got this predicted class? From the model. Now if you pass this, you will get the prediction. But you can you either you can use this you can use this library, or you can also cross verify with the formula. As I said, my precision formula is tp upon tp plus fp. So that is the total true positive. tp means true positive, fp means false positive. So you can get the true positive from this line, where it is actually 3530. So 3530 plus 687, if you do this mathematical calculation, you will also get the same results. So both way you can verify whether it is correct or not, but as sklearn is provide direct way, we can use it. Similarly, recall is as same here, pass the actual class and the predicted class, you will get the 65 is my recall score. But if you want to verify with the formula, it is also giving the same. As I said, what is a recall? Recall is a TP upon TP plus Fn. If you pass the input to this TP upon TP plus Fn, it will also give the 65% as a result, okay, with the mathematical calculation. The next part is the F1 score. I hope you understand what is a precision and recall. Now next is the F1 score. What is F1 score? F1 score, when we want to give equal weightage to precision and recall, we don't want to deviate from for some kind of problem, both are important, okay, then that time we are going to the F1 score. Now what is F1 score? F1 score is a harmonic mean. This is not the simple mean. Now when I say harmonic mean, so normally normal mean is nothing but the add the number divided by the quantity, right? If I say there are the two quantity, you add the actual value of this two quantity divided by the how many quantity, 2. So this is called as a normal mean, but this is a harmonic mean, so that's why formula is coming 2 upon 1 plus precision and recall. Now why we are using harmonic mean? Because it gives much more weight to the low value. So whatever value is low, let's say when you are calculating the F1 score, recall is coming as a low and precision is coming as high, then it will give weightage to the low value score, so that both values are high in that case, okay. So that's why we are considering the harmonic score. Now if you just put the value of formula value of precision and recall here, you will get this formula. No need to read the formula, but all just you, if you can use this as well, 2 into precision, 2 into precision into recall upon precision plus recall, okay. No need to move up. sklearn provides a library which does this is internally. But what is F1? F1 is a harmonic mean of what? Precision and recall. Now as I said, sklearn provides this library. Let's go to the notebook and see how it look like. Now as I said, F1 score I use from sklearn matrix, import F1 score. F1 score is a, and then pass the value of y train phi and y train pred, it will give the result. So we can see that the HJD classifier which we have used for this kind of classification problem, it is giving the 73% as a F1 score. Recall comes around 65 and the precision comes around the 83. Now the question, now we understand what is precision and we understand what is a recall. But the question is that when to use precision and when to use recall. What are those scenario we consider for while selecting the precision or recall? So for that we have, let's look at the some of the example. But before looking at the example, there is a simple way to select the precision recall. Whenever you are saying my precisions are, my false positive is very important for me. False positive means, when we want to false positive means they are actually negative, but my model predicted at positive, that is called as a false positive. So when we say my false positive is important, so during that time we generally use the false, then we generally use the precision. Let's look at the example first. So let's say if you train a classifier, okay, to detect the video that are safe for the kids or no. So you have made one classifier model and you want to check whether that model is performing well or not, and you want to make sure that whatever videos we are sending to the model must predict whether this video is safe for kids or not. Now there are many good videos, say it is not like that videos are good or bad. We are not saying videos are good. What we want to say, whether that video is safe for kids or not. So we are okay if my classifier neglecting some good videos, okay. My if my classifier neglecting some of the good videos, that is okay. That means now if you see the confusion matrix, in confusion matrix okay, we are only focusing, when I say FP is more, so in precision we are only focusing this area, though these are also positive, these are also positive, but we want to focus on this area, okay. So in this case when we are saying precision is important, means we are also neglecting the actual positive, right, means actual good videos. So we are okay if we are neglecting the good video, but we want a model should be more precise, so that the videos, whatever videos are coming, that are safe for the kids. Maybe some bad videos are good for good for kids, right? We are not dividing our videos into the good or bad. We are dividing the videos which are safe for the kids. So in that case, precision is very important. So whenever you feel that my FP, that is false positive, is very important for me, then we must select the precision as a matrix for the evaluation of the model. I hope you understand. Let me clear the screen. Now jump to the when to use the recall. Similarly, if you know the confusion matrix, in the confusion matrix, these are the area. So false negative and the true positive. So whenever we are focusing that my false negative is very important for me, that means then that time we normally select the recall. Now suppose, let's take the example. Suppose you train a classifier to detect the shoplifters on surveillance image. Okay, so you want to check whether that shoplifters on the surveillance image. So it is probably fine that the classifier has only 30% precision as long as 99%. So it's sure that the security guards will get few false alert. Now when it, see, false negative means what? That those are actual positive but model predicted negative. So when these are the false alert, it's okay, the security will guard will give some false alert, but the advantage is that all the good secure ones will get the entry because there is a manual intervention. So in the okay, so in kind of security surveillance instance, it is very important that no negative or no threat must enter into the lobby, or you can say any kind of zone, or you can say, let's say this is my office. We don't want any uh, threat or any only the office person who has office team who has access to this office premises, only they get enter, right? Though for the few of the office person who has a get access, they may not get the entry because of some my model is predicted they don't have the entry, but we have the security guard here, right, who will cross verify with the system. But we don't want my system or my checker or my model allow the threats or who doesn't have access to into the office. So this time I will definitely focus on the recall. So whenever my false negative is very important for me, means I don't want to lose my actual positive value, then I'll focus on the recall as a my matrices to validate the model. I hope I tried my best to explain when to use precision and recall. If you still have any doubt, please do the comment in this video section. I will try to answer your query. Thank you. Now let's jump to the Jupyter notebook where we can see how to calculate the precision and recall. Now, okay, there is a one more important factor before precision and recall. It is very important to look at the how to calculate the decision, how to calculate the decision threshold. Now how to decide which number are positive and which number. Now we are taking the example of whether the number is 5 or not. So for that we have to draw a line, right? There should be a line, decision threshold. Like, let's say if I plot the number on the line, okay, let's say 6 6 5 4 3 5 5, okay, I have to mark as a some threshold, so that from this threshold to the right all the number will be 5, and from this point to the left all number will be the non 5. So how it is very important, once the model is developed we must provide the some kind of threshold. That threshold is normally called as a decision function. Okay, so that model will use those threshold, and if any number is beyond this threshold, the score I mean to say, then it is called as a positive or the negative prediction. So for that we have we are using decision function. So I'm providing one link here from the Geekforce Geeks, which will from which you can understand what is decision function. Decision function is a method that is present in a SPC and logistic regression class, okay, which will generally give the score. Okay, so decision function what will give? It will give the scores, and we will compare that score with the threshold. Now how to decide a threshold? There is some logic. We will definitely talk to you how to decide a threshold. There is some way, there is some practice we are following, but we will compare the score with the threshold and check whether that prediction is a positive prediction or negative prediction. Now how to get the score? We will get the score from the decision function, right? I hope you understand this one. Now now let's move to the next. Okay, so as I explained, this is okay. Let's come to the precision and recall trade-off in later, but let's see in the notebook how to calculate that. Okay, so as I mentioned that, so you will get the score using the decision function. This is already come up with the algorithm. So let's say there is a, we are passing x dot loc dot 0, means we are passing the first number, okay, and then that first number is we are storing in the sum digit. We will calculate the, we are calculating here the score of that number using the decision function. We will get the y score, and here now currently we are setting our threshold 0 manually, okay, and we are checking whether that score is greater than threshold or not. Now we can see that score is 2164 is greater than 0, so we will mark that value as a true. It means we are saying that that number is a 5. It is correctly predicted. Now if we change the threshold, that is to the 8000, okay, now again we are comparing that score with the threshold, and definitely it becomes false because 2164 is not greater than 8000, so definitely result is getting false. So in this way we are deciding the threshold and compare with the scores and decide whether that number is a positive prediction or negative prediction. So because we definitely require some kind of threshold to compare. Now so this is the one way to calculate the score manually, but we don't want to, we want to calculate the score for every numbers. Okay, I'll definitely um, request you all, please go through this article. It will definitely, it will explain very nicely what is a decision function. Okay, now we are using the cross val predict, okay, from which we will calculating the y score for all the number and using that y score we are getting the precision, recall and threshold value. Okay, so when we get the y score, we will pass to the precision recall curve, and in the precision recall curve it is called, we will pass y train 5 y score, and from there we will get the result of precision and recall. Now here we can see my precision is getting 90% for the graph. Now the point is that what is a precision recall curve? Precision recall curve is nothing but the precision recall. So when we are sending, okay, let me, so as I mentioned earlier, how to decide the threshold. So to decide the threshold we are using the precision recall curve and the good part of this, it will give the good value of the threshold. It will give the precision, it will give the recall, and it will also give the threshold. The input parameter for this is required as the y train 5, that is my actual class, and the y score which I am getting from my decision function, right? If you see, I'm using the cross val predict functionality and I'm passing method as a decision function here. So this will calculate the y score. When I pass this to the my precision recall, so what is precision recall curve? It is a axis, it is a axis, or it is a graph between precision and recall. Okay, so it will plot the graph, and accordingly there is some methodology based on which it will decide the threshold and it will give the precision and recall. But there is a trade-off between the precision and recall. Before jumping to the yeah, so we can see now what is a trade-off between, but let me explain with the help of the diagram, and then we will look into the graph. Okay, just a minute, let me clear the screen. Yeah, so now here is the slide. Now let's understand the trade-off between the precision and recall. Now if you look at this thing using the decision function, okay, we have calculated the score for my all the class, right? Let me change the, yeah, I have calculated the I have calculated the score for my all the numbers, okay, and then I have decided the threshold. Now if you look at that, when when I decide this is my threshold, so whatever projection from my right, it will be positive projection, whatever projection from my left, it's a negative projection. Now when I decided this is my threshold, so what will be my recall? So recall will be, so what will be my, let's say, calculate the first precision. So as I said, what is a precision? How many values, how many values are actual positive, that is TP, from my total positive projection. So if you see 1 2 3 4 5, these are the model projection, from which how many are actual positive? Only 4, 1 2 3 and 4. So my results become 80%. So out of 5, only 4 are actual, out of my 5 positive prediction, only 4 are actual positive, so my precision comes around the 80%. Now let's look at the my recall. Now if you look at the recall, what is the definition of recall? How many are, how many are actual positive from my actual positive, how many are true, how many are true positive from my actual positive, okay. So if you look at that, so actual positive values are this one, this one, this one, this one, this one, and this one. So 1 2 3 4 5 6, actual positive value are 6, out of which if I decide this is my threshold, so out of which how many are positive my model is predicted? 1 2 3 4, 4 by 6, so my results become 67%, right? Now let's move my threshold value to this here now, okay. Let's move to the, so how many projections are 3, how many projections are 3, out of which how many are actual positive projection? 3, so my precision is become 100, right? So what is happening here, my threshold is increasing. So we can see when the threshold is increasing, my precision is also increasing. Let's look at the my recall. So how many actual positive? 6, out of which how many my model is projected? Only 3 is projected as a positive, so it's 3 by 6. So what happens, my recall is getting decreased. So I can say that if my threshold, if my threshold increases, my precision also increases and my recall get decreases. Let's look at the this threshold. Now when my threshold is getting decreased, now this line, right, this line, how many, so this will be my prediction, right? So 1 2 3 4 5 6 7 8, from 8 how many is my model predicted correctly? 1 6, right? So it become 6 by 8, that is 75%, and my recall is definitely 6 by 6, that is 100%. So I can say when my threshold is getting less, my precision is getting decreased and my recall is getting increased, right? So this is the, I can say this is a trade-off between precision and recall. When you increase the threshold, my precision is getting increased. When you decrease the threshold, my recall is getting increased. I hope you understand with the help of this diagram. Let me explain you with the help of now notebook, okay. So this is the graph between precision and recall. Now if you plot this graph, you can see that my precision is getting decreased, right? My, let me take the pencil, yeah. My precision is getting, sorry, this is my recall, my recall is getting my, this is, yeah, this is my recall, right? When you increase, so this is a recall and this is a precision, right? So when the threshold is getting increased, precision, recall is getting decreased and my precision is getting increase. Okay, so this is the trade-off between the precision and recall. So now if you look at the, so how to decide the threshold here? Now if you look at this here, so my precision is getting bumpier here, right? So we can decide the whenever your precision getting bumpier, you can take that point. So my threshold is become, my precision becomes 0.90. So that value can be considered as a threshold for your model. So accordingly you can calculate the precision. So that's why we have decided the threshold as a 90. So this code is also will give the threshold automatically using this precision recall curve, or you can with the graph also you can decide. So wherever precision curve is getting bumpier, slightly below that, you can choose this as a threshold value, and you can calculate the threshold, and you can calculate the recall 90 as a precision. So to calculate the, to take that recall as a 90, you just have to use the np arc max. Okay, for the precision is greater than equal to 19. This way you can calculate the recall for that. So this is called as a precision versus recall. Okay, so there is another plot which we can use for that. So this is using the threshold. Okay, this is called as a precision recall versus threshold. So we are passing precision, recall and threshold. There is another graph we can use using only precision and recall. Okay, so this is the precision, this is the recall. Instead of threshold we are only using precision recall. Here we have used threshold, but you can use take a help of this graph. Okay, now wherever you see that my precision is getting decreased, now if you can look at this, my precision is getting decreased at this point. So it is something at the 90 percentage of my precision is getting, my graph is getting slightly less. So you can select the 90 percentage from here. So my precision will be 0.90, and based on 0.90 you can just draw the graph on this, and whatever threshold will be there, you can select that threshold for your model. So you can see that graph starts falling at 80% recall, and you will probably want to select the precision recall trade-off just before the drop. So depending on project you can select the threshold. So there is always a question that how to select the threshold. One is always you have to go to the expert and select the threshold, who has the domain knowledge of that. But if you before that you can use this methodology to select the threshold and discuss with the domain expert to select the threshold. But this is where you can select the threshold. Now there is a next part is to ROC curve. This is the another matrix to decide to decide which model is performing better than other. Okay, so this is called as a ROC curve. So what is ROC curve? ROC curve is nothing but the receiver operating characteristic curve. So ROC curve is nothing but the receiver operating characteristic. This is again another binary tool is used for the binary classifier. Now what is a ROC? ROC curve, it is also called as a graph between the sensitivity and specificity. So it is a graph between the FPR and the TPR. TPR we already know, it is also called as a recall, or it is also called as a true positive rate. So true positive rate means TP upon TP plus Fn. Okay, from actual positive, how many values are predicted, how many is my model predicted as a actual positive, that is called as a true positive. Okay, so it's a many values are predicted positive is called as a true positive rate. So TP upon TP plus Fn. The next is the FPR. What is FPR? FPR, it is called as a false positive rate. So this is a FP upon FP plus Tn. So how to calculate this FP upon Fn? If you say 1 minus true negative rate, so TPR is a true positive rate, TNR is a true negative rate. So true negative rate is nothing but the Tn upon Tn plus Fp. Tn upon Tn plus Fp. So you do 1 minus this, you will get the false positive rate, right? So true negative rate, you can say it's a it is also TPR is also, TNR is also called as a specificity. Okay, it is also called as a specificity. So generally ROC curve is called as a sensitivity versus specificity. So you do this calculation, you will get the APR. So it is a AP upon AP plus TN. If you, when you do this calculation, you will get this stuff. Okay, now the question is that when you should use ROC curve or when you should use the PR curve. So PR curve is generally paper whenever there is a positive class is rare, or when you care more about the false positive. Okay, when you care more about the false positive, then that time you should use the precision and recall curve. Okay, otherwise you can use the ROC curve. ROC curve is also very good important to if you want to compare both models are working fine or not. Okay, now let's jump to the uh, notebook where I can explain graphically as well. So this is the ROC curve. You can use sklearn package to get the ROC curve when you pass the your model y train 5 and y score. Now again ROC curve also require the like precision recall curve, they require the actual label and y score. You also need to pass the same thing and you will get the APR comma TPR and the threshold. And now when you pass this information to the plot the ROC curve, you will get the graph like this. So it is a graph between false positive rate to true positive rate, right? Now this is the graph. Now what is our agenda? We want my value of ROC should be closer to the 0.1. Now it is coming to something, if you look at this point, it is coming something to 0.9, 0.85 or 9 between, right? So similarly this is the way when I pass the threshold as a 90, which we have already calculated, recall 90 precision. So with the help of that we can calculate the false positive rate at the 90. You just need to pass the TPR which is greater than the recall 90 per precision and you will get the APR 90. When you plot this graph you will get this value. So something you are getting threshold as a 0.45, right? So you can also see the score which is a 0.96. so we can see that one way to compare the classifier is the area under the curve. Now this is a ROC, but when you see the area which is under the curve, it is also called as a AUC, right? Now score is very good, right? We can see that using the HGD my ROC score is coming as a 96. But as I say, always use the precision because number of class 5 is very less in my data. So it is always good to check the precision score for this. Okay, now let's use the another library, random forest, for my type of problem. I use the random forest classifier using the random state as a 42 and I'm passing as a forest classification x train y train 5 cross validation as 3. Now remember, in the SPC or any kind of other linear type of model we use the method decision function, but to calculate the score here we are using method called as a predict probability. We can't use as a decision function. So instead of decision function here we are using predict the probability, and then we are passing those predict probability to my ROC score. Okay, so that will call as a, now to get the y score forest you just doing some kind of slicing here. Okay, so these are the probability y probability forest and you are passing, you are doing the slicing. So it contain in the first column, the score normally contain in the first column of the y probability forest and you are saving that thing into the y score forest. You are sending those information to the ROC curve and getting the APR forest, TPR forest and threshold forest. When you pass this information and when you compare the two classifier, now the dotted line is called as HGD classifier and my blue line is my random forest classifier. Now you can see that the area generally, okay, area, maximum area is covered under the random forest curve, right? The area is curve under the random forest is maximum as compared to the as compared to the HGD. Therefore, I can see that the random forest is best fit for my kind of data. Now, but as I said, it's a the number of I is very less, so let's calculate the precision score of random forest, and it is coming something around the coming around the 90 percentage, 99 percentage. So precision score is also good in case of random forest. However, the precision score in the HGD it is coming around the 96. So precision score is also good and my recall score is also good. So this way we have completed the how to use the ROC curve or the precision curve for selection of the best model, and I have also explained what is AUC. So always try to select the ROCS score which is close to 1. If you have any question, please comment, ask in the comment section, and try to like, share and subscribe. That motivates me to do this stuff more and more. Thank you.